Welcome back, everybody. Today we're going to look at Chapter 7, Lesson 4, finding a missing side length given two similar triangles. So triangle ABC and DEF are similar. Find the missing side length. And the missing side length is right here. So we can do this a couple of different ways. Common sense is going to tell me I'm going to look at these numbers over here and maybe look at this, and I can go, wait a minute. If I'm going to go from a 7 to a 42, that's going to be 7 times 6. Let me check that over here. Would 4 times 6 give me 24? Yeah, so let's go ahead and do 8 times 6, and 8 times 6 is going to give me a 48. So I know the missing side length is going to be 48. Now, if you can't do that in your head, there's a couple different ways we can do this. I'm going to go ahead and do something like this. I'm going to say that A and B match D and E. So I would say 24 over 4 is going to be equivalent to maybe 42. No, I can't do that. So I did 24 over 4, so then I'm going to do x over 8. So I'm going to go ahead and do x over 8. Now I can go ahead and just solve this equation here. And again, there's a couple different ways we can do this. You can kind of cheat again, and you can say, okay, 4 times 2 is 8. 24 times 2 gives me 48. If we're going to do this algebraically, you guys, we're going to go ahead and cross multiply. We would do 4 times x, and that would give me 4x. Then I would do 24 times 8, and that's going to give me 192. And then divide both sides by 4, so x is equal to 48. Okay, several different ways we can do that. Now, I do want you guys to realize that I didn't have to pick this 24 and this 4 here. I could have said, all right, 42 over 7. 42 over 7 is equal to the question mark over 4. So x over 4, I can set it up that way. And it really wouldn't matter if this 24 over 4, maybe you decided to do 4 over 24. That would work too, as long as you did 8 over x, okay? Because when we cross multiply, we're still going to get 4x this way. So a bunch of different ways. Okay, let's move on down to the next one. So triangles ABC and DEF are similar. Part A, there are 3 proportions below. The ratios in each proportion compare the length of one of the sides of ABC to the length of the corresponding side of DEF. Complete the proportions. So let's see here. We've got AB over something is equal to 2/3. Well, from A to B is going to be 6. And then let's find the corresponding side. So the corresponding is D to E, and D to E is 9. So is 6 over 9 the same as 2/3, you guys? Yes, it is. So then we know that the corresponding side is D to E. So right here, you guys are going to click, and from the drop-down menu, you are going to do DE. All right, the second one here, we've got AC. Let's see how far it is from A to C. A to C is going to be 10. Let's see how far it is from D to F. That is going to be 15. Let's go ahead and simplify 10 over 15, and once again, we get 2/3. Okay, and the last one over here is BC. So from B to C gives me a 12. And they're similar, right, you guys? So if they're similar, and if this one is 2/3 and this one is 2/3, what do you think this one is going to be here? This is also going to be 2/3 when we're done. So I'm going to clear the screen actually, just so we don't have so much stuff up there. Okay, so let's go back to that one. So from B to C is going to correspond to E to F. So B to C is going to correspond E to F. We already know it's going to be 2/3. Let's just prove that. 12 over 18. 12 over 18 gives me 2/3. Okay, and let's go ahead and do the second part of the problem down below, part B. Choose the correct statement about the answers to part A. So the first statement, you guys, each pair of side lengths compared is not in the same ratio. That's false. The same ratio is 2/3. Let's see, we don't even need to read the rest of that. Each pair of side lengths is not in the same ratio. We're not going to go there. Each pair of side lengths is in the same ratio. This is a coincidence. We would usually not expect this in the form of similar triangles. That's not true, you guys. We would always expect that. So the last part, each pair of side lengths compared in each pair of side lengths compared in the same ratio is in the same ratio. That was a tough one for me to read, you guys. Bear with me on that. This is because the side lengths in each pair are lengths of corresponding sides, and the triangles are similar. That is absolutely true. So we have one more to go. All right, last one. The pentagons ABCDE and JKLMN are similar. Find the length of X. Find the length X of LM. So basically what they want me to do is they want me to find out the distance from L to M, and they are calling this X. So there's a couple different ways we can do this, you guys. We can compare one side, it doesn't matter which side, on the large pentagon to a corresponding side on the small one. So I could say 3 over 2.1 is equal to, now I want to find my missing side. I want to use the missing side. So the missing side is down here with X. So if I did 3 to 2.1, I have to do 5 to X. So I'm going to go ahead and do 5 over X. And then we're just going to go ahead and cross multiply. And when I cross multiply, I do 3 times X, and that gives me 3X. Then I'm going to do 5 times 2.1, and that's going to be 10.5. And then I just need to do 10.5 divided by 3, and that would be X is equal to 3.5. So I want to show you a couple of other things here, at least one. Let me change the color of the pen. We'll go to the green. Let's see what would happen if I compared this side here to this side here. And then if I did 3 over 5. And then I could compare 2.1 over X. So we would end up doing 3 times X, and take a look up here, you guys. We did 3 times X. And so it's going to work that way as well. And let me point out one more here, you guys. You could have done the exact same thing. You could have said this 2 over 1.4, 2 over 1.4 is equal to 5 over X. And you would end up with the exact same answer when you're done. Okay? All right, that's it. Good luck on your homework. Check in with me if you guys have any problems, okay? I'll see you guys soon.